Your configuration files might be silently using outdated settings that could break in future updates. You'll see how to build a FastMCP tool that automatically checks for deprecated options and warns users about risky configurations before they cause problems. The pattern uses structured logging to flag issues like obsolete API keys or dangerously high timeout values, while still letting valid configurations pass through. At MCP tool, async def validate config dict ctx context dict validate configuration with warnings for deprecated options. If old API key in config, await ctx warning. Using deprecated old API key field, please use API key instead. Extra equals deprecated field, old API key. If config get timeout 30300. Await CTX warning. Timeout value is very high, 5 minutes. This may cause issues. Extra timeout value, config get timeout. Return status, valid warnings, see logs. This demonstrates the client-aware validation pattern, where configuration checks happen server-side, but communicate issues directly to the client through structured logging. The technique combines validation logic with real-time user feedback, creating a bridge between back-end enforcement and front-end visibility. What makes this distinctive is its dual role. It both validates input and educates users about potential problems through contextual warnings. The pattern works by embedding validation within tool execution while using the context object as a communication channel. Instead of silently correcting or rejecting invalid configurations, it surfaces issues as actionable warnings with structured metadata, allowing clients to handle them appropriately. This separation of concerns keeps validation logic clean while making the system more transparent and debuggable. This approach matters because it transforms validation from a binary pass-fail gate into a collaborative process. Developers get immediate feedback about deprecated or risky configurations during development, while production systems can log warnings for auditing. The trade-off is minimal overhead for significant improvements in usability and maintainability, making it ideal for APIs, CLI tools, or any system where configuration quality directly impacts reliability. Let's break it down line by line. At MCP tool, async def validate config dict ctx context dict validate configuration with warnings for deprecated options. This is an AI callable tool definition using the @MCP tool decorator. The function validates configuration dictionaries, while the CTX context parameter enables logging warnings for deprecated or problematic settings. All FastMCP tools follow this signature pattern for consistent AI integration and progress reporting. If old API key in config, this checks for the deprecated old API key field in the configuration. It's a backward compatibility measure that detects legacy configurations before they cause runtime errors. The pattern ensures smooth migration by warning users about deprecated options while still accepting them temporarily. Await CTX warning. This emits a warning through FastMCP's context system, surfacing issues to both logs and the calling AI. All tools should use CTX for progress reporting and warnings instead of direct logging. Using deprecated old API key field, please use API key instead. This warning message handles deprecation communication. It alerts users about the obsolete old API key field and directs them to the new API key parameter, ensuring smooth migration while maintaining backward compatibility. The pattern prevents silent failures when legacy configurations are used. Extra equals deprecated field, old API key. This attaches structured metadata to the warning log. The extra dictionary adds machine-readable context about the deprecated field, enabling log processors to filter, analyze, or automatically flag deprecated usage patterns. FastMCP tools should include relevant metadata in warnings for better observability. This closing parenthesis terminates the CTX warning call, finalizing the warning message and its metadata. It ensures the warning is properly logged with structured extra data for debugging, while maintaining clean function syntax.
If config get timeout 300.
This checks for excessively long timeout values using a default of 30 seconds. The get method with a fallback prevents key error while enforcing a sensible default, and the 300-second threshold, 5 minutes, flags potentially problematic configurations that could cause resource exhaustion or connection timeouts.
Await CTX warning.
This emits a warning through FastMCP's context system, surfacing issues to both logs and the calling AI. The async await pattern ensures warnings don't block validation flow, maintaining performance while providing feedback.
Timeout value is very high, 5 minutes. This may cause issues.
This warning message flags excessively high timeout values that could cause operational issues. The 5-minute threshold prevents hanging processes and resource exhaustion, while still allowing reasonable configuration flexibility. Contextual warnings like this help users correct problems before they become failures.
Extra timeout value. Config get timeout.
This attaches contextual metadata to the warning log. The extra dictionary includes the actual timeout value that triggered the warning, enabling richer log filtering and debugging. FastMCP's context system automatically captures these structured extras for observability. This closing parenthesis terminates the CTX warning call, finalizing the warning message and its metadata. It ensures the warning is properly logged with both the human-readable message and structured extra data for programmatic handling. The pattern maintains consistency across all warning emissions in the tool.
Return status. Valid warnings. See logs.
This return statement standardizes the validation response format. The valid status confirms the config is technically acceptable, while see logs directs users to check warnings for deprecated options or unusual values. This pattern ensures consistent output structure across all validation tools. Contextual validation pattern. The Validate Config tool demonstrates FastMCP's non-blocking validation approach, where warnings enrich execution context without halting progress. Deprecated fields and extreme values trigger warnings that appear in logs, but don't prevent successful completion. This pattern maintains backward compatibility, while guiding users toward better configurations.
The warning that speaks is ignored. The warning that's silent is obeyed.